The center of gravity, or G, is the single point where the downward force of gravity acts. The center of gravity is the combined effect of the position and weight of everything on board a vessel. The center of gravity moves toward any added weight, away from any removed weight, and in the same direction as any shift in weight. On a properly managed vessel, the center of gravity should be maintained on the center line for maximum stability. Because it is a point in three-dimensional space, there are three coordinates used to describe its position. The vertical center of gravity, or VCG or KG, is measured upward from the keel. The transverse center of gravity, TCG, is measured from the center line. The longitudinal center of gravity, LCG, is usually measured from the forward perpendicular or from midships. Understanding where a vessel's center of gravity is located and how it moves is vital for a ship's officer because it is the one property of a ship's stability that they have the most control over. As cargo is loaded or ballast tanks are filled, the center of gravity moves accordingly. How well an officer understands this principle will keep his vessel afloat in heavy weather. Center of buoyancy, or B, is the single point where the upward force of buoyancy acts. It is located at the geometric center of the displaced volume, or the area of hull beneath the waterline. When a ship rolls in the water, the shape of the area beneath the waterline changes. The center of buoyancy is constantly moving to stay in the center of that area. The key to understanding stability is understanding how the center of buoyancy moves. G and B have equal force acting in opposite directions. As a vessel rolls, the distance between the downward force of G and the upward force of B creates a righting moment that returns the vessel to the upright position. A moment is nothing more than a force or weight multiplied by its distance from a particular point. Think of it as a lever. A moment can have a greater effect because the distance increases or because the force increases. In the imperial system, moments are measured in foot-tons. The effect of the longitudinal difference between G and B is trim. Trim is defined as the difference between the forward and after drafts. The opposing forces of G and B across the trim arm create a trimming moment that causes the vessel to trim around the LCF. Keep in mind that the deeper draft of a ship's trim will always be on the same side of the trim arm as the LCG. If the LCG is forward of the LCB, then the forward draft increases. If LCG is aft of LCB, then the after draft increases. Moment to trim 1 inch, or MT1, is the moment to change the trim of a vessel by 1 inch. In the metric system, this is the moment to trim 1 centimeter, or MTC. These final concepts are the core of ship stability and trim. Every officer needs a working knowledge of these terms in order to understand the stability of their vessel. Heel is the angle a ship assumes as a result of an outside force, such as wind or waves. Unlike heel, a vessel is said to list if it is resting in the water at an angle without an outside influence. Normally, this is due to what is called an asymmetrical load, an uneven load that causes a vessel's center of gravity to move off of the center line. A list should be quickly and easily corrected. As we've seen, when a vessel rolls, B moves in the direction of the roll and out from under G. The metacenter, or M, is the intersection of the upward force of B when a vessel is upright and when it is at an angle. Think of it as the center of the arc that B moves through as a vessel rolls in the water, like the anchoring point of a pendulum. It is considered to be on the center line at small angles of heel. The location of the metacenter is provided for the ship's officers by the naval architect and is a key value in calculating stability. The vertical distance between the center of buoyancy and the metacenter is called the metacentric radius, or BM. Once there is a horizontal distance between the center of gravity and the metacentric radius, the opposing forces of gravity and buoyancy create a righting moment that returns the vessel to its upright position. This horizontal distance is called the righting arm, or GZ. The righting moment, the rotational force that rights the ship, is the length of the righting arm multiplied by the vessel's total displacement. Km is the vertical position of M, measured upward from the keel. Metacentric height, or GM, is the vertical distance between G and M. When we put these things together, we see the ship's stability triangle. This shows us that the larger the GM is, the longer the righting arm, or GZ, will be. The longer the righting arm is, the greater the force of the righting moment will be, and the ship will have a greater ability to right itself. For this reason, GM is used as the standard measure of a ship's initial stability. This is the stability for small angles of heel, usually less than 7 or 10 degrees. When a ship heels any more than that, its metacenter moves off of the centerline and stability becomes a more complex problem. Initial stability is still used as the standard measure of a vessel's stability, however, because if a vessel has enough initial stability, it is believed to have sufficient stability for larger angles of roll. Knowing the fundamentals and terminology of stability is just the beginning. Once you're comfortable with the terms of stability, you can begin to understand the stability calculations required of every officer. As you continue to study stability, you will become familiar with the hydrostatic tables provided for your ship and use them to help you find its required stability. You will use initial stability to determine your ship's overall stability, as well as range of stability, maximum righting arm, and danger angle. Understanding the stability of your ship is the key to making every voyage a safe one. A vessel's stability should never be taken for granted. Many assume the naval architect took care of it in the ship's design. Most crew members give it little thought. A responsible officer does not have this luxury and must always be aware of their ship's motion and understand what it means. Yes, firefighting, housekeeping, and navigation are very important, but none of it matters on a ship that can't stay on top of the water. Only when your ship is upright and stable are you in a position to deal with anything else the sea throws at you.